op-amp integrator. This is the circuit diagram for op-amp integrator. This is IC741 symbol of op-amp. Here we have to connect the input square wave, and this is RC circuit, resistor and capacitor, and we have to record the output with respect to ground. This is the circuit diagram. This is the circuit actually you have to use for this integrator. This is IC741 op-amp operational amplifier. This is input terminal. Over here we have to connect the square wave. 12 volt positive VCC. This is negative 12 volt. This capacitor and resistors are connected over here, and output we have to record in number 6 and ground. This is dual power supply. This is dual power supply. With respect to ground, 12 positive and 12 negative we have to connect to the circuit. This is CRO. With the help of this we have to trace the output waveform, and this is the frequency generator from which we have to connect this square wave. From this dual power supply positive terminal, connect to the positive 12 volt, that is number 7 terminal of op-amp. Then negative terminal of this dual power supply connected to number 4 of this op-amp. Generator positive, it is connected to input terminal of this integrator circuit, and negative terminal is connected to ground terminal. The ground terminal of this dual power supply is connected to ground. CRO, make the connection of this probe by rotating it clockwise. Connect this for input wave, this black to the ground, and red to this red for input wave, and this another probe for output, black to the ground and red at number 6 to see the output wave. This is the complete connection for this integrator circuit. Okay. Switch on the dual power supply, frequency generator. Set the frequency generator. Frequency is 1 kilohertz. For 1 kilohertz frequency, for this circuit, input wave we connected is square wave, and corresponding output integrator circuit is, this is the output circuit. So this is showing the charging and discharging of the capacitor. So see here, for positive going edge and negative going edge, it is showing the charging and discharging of the capacitor, and this is the integrated output of this circuit. Okay. Trace this input and output on your graph paper by taking the scale exactly on the screen and plot it on the graph. Then change the frequency, and for another frequency, say 1.5 kilohertz or any convenient frequency, you have to see the another waveform and trace this another waveform for the second frequency on your graph paper and write your conclusions.